Okay, cool. Okay, LinkedIn. 433 minimum generic mutations. So a gene string can be represented by a character long string with choices from A, C, G, T. Suppose we need to investigate about mutation from start to end. Not sure what that means yet, but where one mutation is defined as one single character changed in a gene string. For example, some string to another string is one mutation. And this is because the T changed to an A, I guess. Also, there's a given gene bank which records all valid gene mutations. A gene must be in the bank to make it a valid gene string. Okay, I don't know what that means yet. Now, given three things, start, end, and bank, your task is to determine what is the minimum number of mutations needed to mutate from start to end. If there's no such mutation, return 1. Starting point is assumed to be valid, so it might not be included in the bank if multiple mutations are needed. All mutations during this sequence must be valid. You may assume the start and end string is not the same. Right off the bat, I would say it, it's kind of, I mean, some of it is just prompt design is a little annoying, to be honest. In that if you need, feel like I didn't understand what I'm reading up to. I mean, I have some understanding of what I'm reading, but I didn't really understand like the real constraints of the problem until the notes, which means that basically, now rereading it again, basically it's just from you're trying to get from start to the end, and each intermediate in the shortest number of mutations, and each of those intermediate mutations need to be in this, I guess, a list. There should be a map or a set bank. Okay, I mean, so that's fair enough. Uh, yeah, so I mean, that should be okay. Yeah, I mean, I think the kind of yeah, I mean, I think for me this is a very straightforward shortest path problem. Um, yeah. So this is the shortest path problem. I mean, I don't think there's too much confusion here. You just need to make sure that yeah, each mutation needs to be in the bank. Uh, I think the thing I'm trying to think is, uh, hmm, yeah, I mean, I think this is really so some consideration about kind of like the size of the problem space is one. I think because each gene string is an 8-character string and there are only 4 possibilities, that's 4 to the 8 or 2 to the 16, which is, I don't know what 2 to the 16 is. No, but so yeah, 2 to the 16 is like 65,000. So like, so you can actually essentially, brute force it or whatever. Yeah, I mean, I'm not brute force it, sorry, but like you could, with 65 possible like steps in the way, you could essentially like, go through all of them, and that'll be okay, right? As long as you do it in a reasonable amount of time and way. Like if you're not doing something like n square or something, and then it'll be fine. But because this is, um, yeah, but I mean, essentially, this is shortest path, and shortest path. There's a lot of different ways you can do shortest path. And because each of these distance is one, even a breadth first search should be okay. I think, yeah, I mean, I think this is essentially a breadth first search problem for me. I think there are different ways to implement this breadth first search, and what that means is how you define the edges, either implicitly or explicitly, or and how you define the queue. I think the queue part is actually okay because the maximal size of the queue is 2 to the 16 again, which is, like, and that's like a really weird like edge case where you insert everything in the beginning. But otherwise, I I think the other thing I'm trying to think is, yeah, I mean, part of me wants things to be, I don't know if this is meant to be an intentional trick or not, but because none of the examples pointed out, but it is possible that you need to, I think one maybe trap is that it traps people into thinking that maybe like you could do it in 8 steps, maybe, or, but it may actually need to take more. For example, let's say you have AAA, maybe, and the N is just say CCC, and your bank could be, I don't know, ATA, say, or AT, and then, I don't know, CCT, I guess ACT, something like that. I don't know if this is right, but uh, so something like this, you would go from AAA to AAT to ACT to CCT and then CCC at the end, right? So this is 4 steps, even though there are only 3 characters. So that may be one kind of maybe gotcha that I mean that I would look for people to maybe do. Like if I was an interviewer, I'd be like, oh yeah, no, can you think of why this wouldn't work? And this is why it wouldn't work, right? Because well, yeah, I mean, just an example where it takes 4 steps to change 3 letters. So something like that. So otherwise, I think this is just a straightforward breadth search. Again, I'm thinking a little bit about how to kind of do things in a smart way to kind of incorporate the bank as an edge. I think some of this is also a little tricky in that it depends on the size of the bank. Like what is the maximal size of the bank, and these are considerations I might maybe factor in, but I think for now, because we don't know the size of the bank, I'm going to do something naively, and then if something, I don't know, I mean, if it fails, it fails, and then we'll figure it out. Cool. I wonder if you need to zero. I think before it was just because there's some weird things with reverse iterators and so forth, but maybe not. I don't know. Might as well just put it in. Um, Actually, this is probably not necessary. You'll probably do it on the NQ. Nope. I don't want to do it. Okay. Now this is kind of the mm, this is kind of the thing that I would maybe try to figure out what to do. I think actually, hmm, I, I think initially at least without thinking too deeply through, um, I was thinking of maybe just go, like in this case, I would maybe go do a folder for item in bank or something like that. It's like if item with distance, let's just say distance of item and current is equal to one, then you and Q item, right? Maybe something like that, and that's okay. But I think this is probably not as clean as it should be, or at least like it's a little yucky because bank could actually be big. I think what I want to do is actually create an adjacency list. Um, so this, I think if bank is huge, then it could be an issue. Um, but no, because let's see, right? For each string, each 8 character string, it only has, so each character has 3 mutations times 8, right? For each character, so that's only 24. So each item in bank can only have an adjacency list of 24, so you just check against that. Okay, yeah, let me do that. Okay, well, first of all, let's comment these out into now real code. Make sure this compiles, because I always forget. Oh, not compile, but no. I'm thinking. Oops. Still thinking in Go sometimes. Okay. I mean, well, I didn't really output anything, so. Yeah, okay. Oh. Oh, is it always true that the n is in the thing? Okay, I guess it doesn't really matter whether. Okay. Well, that actually, I guess maybe make things easier. It doesn't really change the way I'm going to do things. So since I'm already doing it to a set, but okay. Okay. Now what I want to do is just change one character, right? Okay. Well, yeah. Okay. Let's do it this way. Naming is hard. That's the trouble I'm having with. Okay. Also, I realized that we don't use underscore case, but oh well. It's too late. Enumerate. Okay. No, it doesn't really matter. I guess this is always 8, actually. And then for in theory, I should maybe put this in a constant or something, but something like that. And then well, something like that. All right, let's see how that goes. Well, can't say that went well, but some weird thing going on. That looks okay. Does look okay. Why is this? Oh, because okay, fine. Oh my god. Because for each of those, this combination. Okay. Okay. That worked okay. So now that we did the pre-processing and creating the adjacency list, now we can just do for next in next I guess is a keyword next. Adjacency list of current one, and then the final step is you're checking. Only one, I think, if there's no such mutation, but otherwise, actually, not that maybe they've tried to force, but you actually cannot add that. But all right, this is roughly right. Let's take a look. Oops. Oh, I guess start. Okay, fine. Does n have to be in it? Oh, starting point assumed to be right. Okay, so I guess I could just add this. Okay. I'll copy and paste to do the. Well, I guess this don't need differing here. Cool. Well, I got the right answer, but I think I messed up copying and pasting the. And okay, it's not the same as the example. That's all. Oh no. Oh no. Goes to this. Well, I guess we could just print it out. Prints the first one. Oh man, how did I not? This is pretty bad. I mean, yeah, remember to add stuff to the queue. That helps. But this is why you test things so that you catch silly mistakes, like a core part of the problem. But we can confirm that. Actually, maybe that's not true. I was going to say we can maybe confirm that negative one case is not true, but we should test that as well. Let's just say the n is not in there. Okay, so that works. Yeah, okay, that's just man, no YOLO. Actually, maybe I should test it a little bit more. Okay, so that works. Yeah, so I mean, I think this is a relatively straightforward problem with some caveats. I think actually, now that I've done this problem, I actually like this problem more than I thought it would. It's essentially, like your difficulty is still a breadth first search or shortest path problem. But the interesting part of the problem is that there's some pre-processing, and that pre-processing requires you to actually think a little bit more about kind of the constraints of the problem. The only constraint that they the only constraint that they really gave you is the fact that it's a character long string and the four characters in the alphabet, which kind of from that I think the insight that I had, which came a little bit later than the initial one, was that each of these things has a maximal of like you can only have 8x4, 8x3 maximum number of edges for each of these string nodes, and from that that makes it way easier to kind of figure out what is the right way to implement shortest path. And in this case, you pre-process everything so that it all you get at most is 65,000 entries, each with 24. That's I don't know how many is, but that's less than a million, right? Yeah, that should be less than a million. Maybe a little bit more than a million. Either way, it's way more tractable, and in this case, it allows us to keep it linear for some definition of linear, and yeah, I mean, I think I really like this problem. I think as an interviewee, definitely like there's some insights that I didn't actually think about that much. When at first I was just like, oh, it's another first search, but actually there's some kind of fun, like analysis around the balance of the problem that's not like in your face about it. So I like this one. Maybe it's a little fancy, or like maybe you need to kind of think a little bit. But actually, I really enjoyed this one. It's something that I could very conceivably, do this as an interviewer, just because of those points I listed, and kind of see what the interviewees' thought process around some of these, like just from these like little bits and pieces of input bound. Like, how do you figure out like how, I want to see how the interviewee like think about solving that problem. Like and at its core, it is a breadth first search. So that part is actually the easy part, but that might actually not actually be the tough part of the problem. And I really enjoyed that there's some layering to it. And in terms of my code, I mean, I definitely could modularize this a little bit. That's what I would say as an interviewee. And as an interviewer, I would ask them what they can do. And there's some questions about maybe possible optimizations. But overall, I really dig this problem. And yeah, I mean, I could easily see myself giving this problem. And it probably has around the right level of difficulty. Well, assuming that people haven't practiced and seen it before. But cool. Yeah, I really, yeah, thanks, UK Chang. Yeah, I actually do end up liking this far more than I thought I would because yeah, like I said, at first I was just like, oh, it's another easy breadth-first search, but actually, like I said, the breadth-first search is actually not the hard part, and it forces you to think about the balance of the question, which I actually dig more than I thought I would at the initial beginning, and and this is and none of the component the part I like about it is that none of the component requires any like advanced math or crazy like algorithms or anything. These are all like things that most engineers are equipped with. It's just like you know how do you get from point A to point B? Maybe a little pun intended now that I think about it, but like in terms of you know yeah, and this allowed me to kind of dig into how the interviewee thinks about like constructing the problem and construct in this problem the real problem it seems like is to construct the graph. I maybe implicitly, maybe explicitly. You can even say that like I did this explicitly and put it in a map, but you can actually if you want to be a little bit smart about it and you can actually I don't know what my oh, actually, I didn't end up using that much memory anyway, which is actually somewhat surprising. But in theory, if you want to optimize memory more, you could like essentially put this loop like here. And I know that there's some stuff about like creating a lot of new strings and throwing them away. So there's some definitely constant optimizations that we can do for sure. But some of it, like if you like I said earlier, because if you do an analysis on the bounds, like okay, maybe you don't need optimizations, but if I was an interviewer and we have 20 minutes left because you finished the problem too early, then that's the kind of stuff that I would ask, like, hey, how would you think about optimizing this? How would you like, do you need this in memory and stuff like that. I think this is kind of pretty cool, and the even more things that you can do, or at least I didn't do it initially. So cool. Yeah. So